Hello friends, good afternoon to all the first year BTech E&TC. I have today introduced with the one important subject that is nothing but basic electrical engineering and digital electronics. So today we have introduced with the unit 1 for DC circuit prepared by Professor Dr. B.V. Patil. So this video is already available on Department of E&TC YouTube channel. So it is the official departmental YouTube channel. So we have to see all the subject related videos on that video channel. So it is the very important effective topics for the first year engineering for all the branches. Today, the Shirpur Education Society, R.C. Patel Institute of Technology and Autonomous Institute affiliated to D. Batu Lorere. So welcome to all Department of Electronics and Telecommunication Engineering. Vision of the institute to become a leading institute in technical education, fostering innovation, research, ethical values and sustainable development for the betterment of the society. Mission of the institute to impart the high quality technical education through innovative and interactive learning process and high quality globally recognized instructional program, fostering a collaborative scientific temper among the student with ethical responsibility toward the society, preparing the student from diverse background to have aptitude for employment, entrepreneurship and research with a spirit of professionalism to contribute to nation's sustainable development. Vision of the department to produce the competent electronics and telecommunication engineers with a commitment to serve the society. Now, this is the outline of Unit 1 for DC circuit for basic electrical engineering and digital electronics subject. First of all, we have to introduce with the concept of currents, then concept of voltage, concepts of power, active elements, passive elements, then types of electrical sources. It contains ideal sources and practical sources. Now we start with the first parameter, that is nothing but charge and current. Electric charge or electricity is mobile, means in having positive charge moves in one direction while negative charge moves in the opposite direction. Motion of the charges creates electric current. Therefore, conventionally takes the current flows as the movement of positive charge that is opposite to the flow of negative charge. Therefore, as shown in the figure, there is a piece of conductor having number of free electrons and electron carries negative charge. They are attracted toward the positive terminal of battery. That is nothing but we can form the conventional direction of current. Current is nothing but rate of change of charge, that is nothing but dq by dt. Therefore, 1 ampere current is equal to 1 coulomb charge per second. Similarly, in circuit element, there is the first element is your current. Current, the flow of free electrons in a conductor is called as electric current. Current is the rate at which electric charge flows past a point in a circuit. In other words, current is the rate of flow of electric charge. The electric current is defined as the time rate of charge. Therefore, the unit of current is the ampere. The symbol for the current is I, capital I or small I. And therefore, we can express as 1 ampere is equal to 1 coulomb per second. Second parameter is voltage. The potential difference between the 2 points in an electric circuit called as voltage. Electromotive force is the proportional difference in charge between the 2 points in an electrical field. Voltage, or it is also called as potential difference, is the energy required to move a unit charge through an element measured in volt. Its unit is voltage or its volt, simply volt. It is denoted by or represented by capital V. So this is the analogy to get how to differentiate between current and voltage. So as shown in the figure, voltage drives the free electrons, and similarly it is the electromotive force. Current is nothing but flow of charge, and resistance opposes the flow of charge. So this is the basic analogy and how to differentiate between current and voltage we can see in that diagram. Then next parameter is power. Power is nothing but the rate at which the work done by electrical energy or energy supplied per unit time is called the power. Power is the rate at which the energy is expanded or the absorbing. The power denoted by either P or small p. It is measured in watts. So P is equal to V into I. Next, we can see what is the network and what is the circuit. So network is nothing but interconnection of two or more simple circuit element is called as electric circuit. And similarly, circuit is nothing but a network contain at least one closed path is called as electrical circuit. Next is your active element. So in electrical circuit, the sources of energy are called active element. Therefore, they may be voltage source or current source. So active element is nothing but capable of generating energy. For example, generators, batteries and operational amplifiers or transistor, etc. We can see the passive element. So passive element is nothing but these elements, they can store in the form of electrostatic or electromagnetic energy or dissipate energy in the form of heat. So basically the passive element is not capable of generating energy. So example of passive element is resistance, inductor and capacitor. So first of all, what is the resistance? Resistance is the property of substance which opposes the flow of current through it. The resistance of the element is denoted by the symbol R and its unit or resistance can be measured in ohm. Similarly, inductor, it is the property of the substance which stores the energy in the form of electromagnetic field. The inductance of an element is denoted by symbol capital L. It is measured in Henry. The unit of inductor or inductance is Henry. Similarly, capacitor, it is the property of a substance which stores the energy in the form of electrostatic field. The capacitance of the element is denoted by the symbol C, and capacitance can be measured in farad. Its unit is farad. So these are the some abbreviations related to the units, matrix units and conversion. Pico is nothing but 10 raised to minus 12. Nano is nothing but 10 raised to minus 9. Micro is nothing but 10 raised to minus 6. Milli is nothing but 10 raised to minus 3. Kilo is nothing but 10 raised to 3. Mega is nothing but 10 raised to plus 6. And giga is nothing but 10 raised to 9 plus 9. Now we start with the first important convention, that is nothing but electrical source, or simply we can call it as source. A source is a device which converts mechanical, chemical, thermal or some other form of energy into electrical energy. In other words, source is an active network element meant for generating electrical energy. So there are two kinds of sources. One is independent source and other is dependent source. So independent source is nothing but an active element that provides a specified voltage or current that is completely independent of other circuit variable. Symbolically, it is denoted by circle. Similarly, dependent source is an active element in which the source quantity is controlled by another voltage or current, just like transistor, operational amplifier and integrated circuit. So symbolically, it is denoted by the diamond in the circuit diagram. So sources, the various type of sources are available in the electrical network are voltage source and current source. So basically a voltage source has an forcing function of EMF, whereas the current source has a forcing function of current. So these are the independent sources. So sources is having basically two main type. One is voltage source and second is your current source. Voltage source is also having two important type, ideal voltage source, practical voltage source. Similarly, current source is also having two types, ideal current source and practical current source. So basically we have start with the first part, that is the voltage source having the ideal voltage source. So what is the concept of ideal voltage source? So voltage source is a two-terminal device whose voltage at any instant of time is constant and is independent of the current drawn from it. Symbol of ideal voltage source is as shown in the figure 1. Such a voltage source is called as ideal voltage source, and basically the internal resistance of the voltage source is ideally 0, or we can simply call it as the source resistance of ideal voltage source is 0. Therefore terminal voltage remains constant, that is VL we can getting across the V. So RS is equal to 0 as shown in the figure A. Therefore practically an ideal voltage source cannot be obtained or cannot be formed. Ideal voltage source is independent of the load. So as shown in the figure A, we can see the nature of ideal voltage source. Similarly, we can form the practical voltage source. So what is the concept of practical voltage source? So practical voltage source is nothing but the sources having some amount of internal resistance or source resistance are known as practical voltage source. And due to this internal resistance, voltage drop takes place and it causes the terminal voltage to reduce. That is, the terminal voltage across AB, VAB is less than V. The smaller the internal resistance of the voltage source, more closer it is an ideal source. So as shown in the figure B, we can see the nature of practical voltage source. Similarly, third is your current source, ideal current source. So as shown in the figure, the symbol of ideal current source is there. An ideal current source is a two-terminal circuit element which supplies the same current to any load resistance connected across its terminal. It is important to keep in mind that the current supplied by the current source is independent of the voltage of the source terminal, and therefore ideal current source has an infinite resistance, that is internal shunt resistance is infinite, therefore RSH is infinite, and therefore ideal current source are not available directly but they are derived from the voltage source. So as shown in the figure C, we can see the nature of ideal current source.